Welcome to our session on sampling and estimation. The first question is, why do we sample? We sample for many reasons. To start with, a sample is more accurate than a population. The sample is a small unit out of a bigger population. It's a subset of the big set. So if you have A and B, B is called a sample. A is called the whole population or the census. Sampling can be done for the following reasons. Number one, a sample may be more accurate. Accuracy level has been proven under sampling to be higher when we have a small population. So it is given by Z S over A, or the error term. So a sample may be sufficient. You don't need to drink the whole drum of Monkoyo to know it's ready. A sample will be sufficient for you to ascertain the readiness of the Monkoyo. Time constraint and financial constraint are key reasons why most people will do sampling. I'm gonna sample because I don't have all the time to do the whole population in Zambia. For instance, I'm doing a research on the impact of COVID in the health sector. It may be impossible for you to meet all the health centers in Zambia. So you're going to use one sample, generalize it. Of course, sampling has a generalization error associated to it. Financial is about money. Your budget is required when you're doing a proposal to give an approximation of how much you're going to spend. The universe size, no matter how much time you have and money, it may be impossible to know how many babies are born. Destructive nature of sampling. Have a cure for HIV. You can't use it on all members of the HIV/AIDS world. You are going to sample it on a few to see how the Sondership formula works. And we have two types of sampling. We have what we call probabilistic and non-probabilistic methods. Probabilistic sampling has about 6 of what we call simple random sampling, systematic sampling, cluster sampling. We also have what we call quarter sampling, stratified sampling. What are these types of sampling methods? So probabilistic sampling has to do with numbers. So on the probabilistic methods, we have what we call simple random sampling method. Now, what is simple random sampling methods? This is where we pick respondents at random. Now, this is done to negate the degree of biasness. So the simple random sampling methods are done to negate the degree of biasness. So every member here will have an equal chance of being selected. Your sampling frame should include the whole population. So to conduct this type of sampling, you will need to use simple tools like a simple random number. For most students that I take for research, by the way, you need to start thinking of your research now, who do not pass through me, fail to even ascertain the sample size to be collected, because you need to justify, why am I picking 10 people out of the whole population of 1,000? So you need to give a sampling formula. We have what is called systematic sampling method, which is also similar, quite similar to simple random sampling. But here we're actually using a slightly easier method where each member is listed with a number. But instead of randomly selecting them, you are generalizing at a regular interval, every 10th, every 4th, okay? For instance, employees in an alphabetical order, and you pick 10, every 10, every 10. We also have what is called stratified sampling method. This one involves you dividing the population into what are called subpopulations. These ones may differ in different ways. And these subgroups are called strata. They're based on different relevant characteristics like gender, like the age range, like the income bracket, like the job role. You see where you have top, middle management, and lower management. You're going to pick in each of them a simple random number. For instance, in a company where you have 800 females, 200 males, and you want to select and from each group equally. So you basically choose 20 from each group, 20 male or 20 females, or you use a strata of gender to pick based on the population size, 20% from the males and 20% from the females. We also have what is called cluster sampling. Cluster sampling really involves you dividing your population into subgroups. Now, each of these groups should have similar characteristics. Abatonga, Southern Province. Ababemba, Northern. Abashpata, Eastern, all right? Then you're going to do a multi-stage sampling, where you're going to pick from each cluster a certain sampled number. So we also have what are called non-probabilistic sampling methods. Non-probabilistic sampling methods, we have what is called convenience, purposive, snowball, quarter sampling. Now, convenience is simply a sampling method that you may happen to like most of your students when you're doing your research, because it's very easy and very cheap. Because here, you're only going to get data right at your doorstep. As a student, you would think of conducting a survey in a topic. It will probably be within your town. Why would you want to do a sample from Mwinilunga when you're staying in a northern province? But you can get it from STEM education center. So this is what we call convenience sampling method. We have purposive sampling, which is also called judgment sampling method, which involves the researcher using their expertise in selecting the most useful samples. Now here, when you're dealing with purposive sampling, like I said, not all intelligent people can teach, not all talkative people can speak. Here, statisticians will use this kind of sample method to be effective. They define their criteria to say, I specifically collected these sampling units because they were more willing or they were experienced. Okay, you're using experience. Snowball kind of sampling method is a sampling method where you recruit participants using other participants. Like a snow grows from a small ball, you're getting contacts. It's more investigative. And usually the police use this to investigate. So basically, this is more about sampling procedures. And when we go into numbers now, we're going to come up with what we call a sample size formula given by Z squared, S squared over E squared, where N stands for the sample size, Z stands for the Z score, and E stands for the error or for the level of precision. So we have our N sample size, our S squared, the variance, and we have our E for the error, and we have our Z score, for which I will teach you some. So we have what we call confidence levels. How confident are we? The most common confidence levels are 99, 98, 95, and 90. The difference from 100 is called the level of significance, SL, which is 1%, 2%, 5%, and 10%. When we divide the level of significance by 100, we now call that our alpha. So this is 0.01, this is 0.02, and this is 0.05, and this is 0.10. And when we calculate our Z, which I'll teach you in another lesson, not for now, Please don't ask me how I found these figures. Just master them. This is 0.58, 2.33, 1.96, and 1.645. This is for a two-tailed test, and now estimation and sampling is under a two-tailed test, and so we're going to dominate on just this. So our Z is 99, level of significance is 1%, our alpha is 0.01, our Z is 2.58. 98, 2%, 0.02, 0.33. 95, 5%, 0.05, 1.96. 90%, 10%, 0.0 or 0.10 is just 1.645. So I'm going to ask you again. Ladies, the way you remember when that man says whatever he says, I want you now to channel that memory, mathematics, with terrible exactness. Let's try to remember our important table. So we have 4 key confidence levels, starting from 99, then we got what?
98.
98, then
95.
95, then
90.
90. Then we have a level of significance level, which we have as what?
1%.
Then
2%.
Then
5%.
Then
10.
Then our alpha level will be
0.1.
Then
0.02.
0. What?
02.
Then
0.05.
Then
0.1.
Great. Then when we have our Z here, we have what?
2.58. 2.33. 1.96. 1.645.
Excellent. All right. And we have the formula for N as what? N is equal to?
Z squared. PQ. Or S squared, which is PQ. Over A squared.
Or our N is what?
Z squared. PQ.
Over E squared. Correct. You're the only one who was in class. Then when we go to confidence interval, we have mean plus minus Z, standard deviation over square root of
I have a question. For the Z, were we calculating it or you just put up the numbers?
They're calculated. I said I'll teach you in the next class how we calculated those numbers because we only have
all right.
Yes. Okay. So with that being said, we're now going to answer a few questions to find the sample size for following. Suppose we're being asked to find the missing figures. Find N if our alpha is 0.05 and our standard deviation is 16 and our error is within plus minus 2. That is question 1. Question 2, find the sample size if our level of significance is 1% and our variance is 16 and we are within plus minus 5. At C, find our sample size if our confidence level is at 90%. And we have our P as 0.2. Okay, to be within plus minus 5%. So the solution here, so to determine which formula to use is dependent on what has been given. Our N here will be Z squared, and then standard deviation, S squared over what? E squared. So what is our Z at alpha 0.02?
$1.96.
Great, because this is 95%. All right. So before I go there, I want to do, can you remember? So let me put these figures randomly. And since I can see your names there, the goodness with Zoom is you can't hide. Just point your name. And, you just tell me what, just give me what the Z is, all right? Just give me what the Z is. I don't want any trouble. Just give me what I want. Yeah. Going to okay, so let's quickly move. Just give me the Z figure there. We'll start in that order. Fred, Kai, Kafula, Marcel, Mona, Patricia, Sylvester, Tamara, Webby. Quickly. What's our Z here? Z here?
That's 1.96.
1.96, correct. Then here, next one.
2.58.
2.58. Okay, is it correct?
No.
It's 2.33.
2.33, correct. Here.
2.58.
2.58. Next. So when you answer, you point at any other person to answer. I think it'll be, we're using a simple random sampling now. Next.
1.645.
1.645. Mona, point at somebody else. Next.
Fred.
Fred, what's our answer here?
1.645.
1.645. Coincidentally, point at somebody else here. Here. Quickly, pick any name randomly so to move quickly.
2.58.
2.58. Next.
2.33.
2.33. Next.
Is it 2.17?
Yes. Wow. What's your name? Mona. Yes, 2.17.
Yes.
I didn't teach this one, yeah? You're in the class where I taught this. Okay, great. Then here.
0.58.
0.58. Next.
0.33.
0.33. Next.
1.96.
1.96. Next.
1.645.
Excellent. Once you get the sum to your neck, then you know where these figures are coming from. So where there is 0.05, we put what? 1.96 squared times where there is S16, 16 squared. And our error comes in the term within. So within, what are we finding here? 2. What are we getting here? This is question number 1. Question number 2, we're still using the same formula. N is Z squared, S squared over what? E. So what is our Z here? What is our Z?
Two points.
The subscriber call is currently busy.
Okay.
Please try more later.
2.58.
2.58. Okay. Then 1.58 squared. Then times what?
16.
16 over.
5 squared.
Why are we not squaring the 16?
It's already S squared.
Good, it's already
16.
squared, yeah.
Yeah.
So what are we getting? Then when we go to the third one, which formula are we using? Formula 1 or formula 2? Formula 2. So our Z is what? What is our Z?
1.645.
Okay, and our P, 0.2, meaning the remainder is our Q. We subtract 0.2 from 1. So to get our Q, we get 0.8. Then within plus minus 5%. So since the percentage is in what? Decimal point, you put it there. All right. Any questions so far? Any questions so far? We'll proceed. Clear? All right. My people perish because of what?
Lack of knowledge.
Lack of knowledge, correct. So confidence interval now, to ask you find the confidence interval when our N is 36, our standard deviation is 12, our mean is 10, and our alpha is 0.05. But B, find the confidence interval if our N is 100, our P is 30%, and our level of significance is 1%. So this is confidence interval. I gave you the formula that depending on what you're given, the formulas are given by X bar plus minus Z, standard deviation over square root of N. Or confidence interval is given by P plus minus Z PQ over capital N. So part A will be formula 1. What is our confidence interval? Our mean is what? 10. Our Z at 0.05 is 1.96. 96. Our standard deviation is 12, and our N is 36. So when you divide our 36 square root into 12, we're going to get a 2. So this 2, we multiply it to the Z, we'll get 3.92. So we get the lower bound by subtracting 10 minus 3.92, which gives us 6.08. And we add to the 10, we get 13.92. So you always start with the smaller figure, which is called the lower bound, and you go to the upper figure, which is called the upper bound. So dealing with part B, we're using proportion. So our P is 0.3. Our Z is at 1%, which is 2.58. So if our P is 0.3 or 30%, meaning our Q is what? 70%. The two must add up to 100. So you put our 0.7 here over our N, which is 100. Here we're going to have 0.3. Here we're going to have 2.58. And here we're going to have 0.3 times 0.7 divided by 100. Okay, then you square root it to get 0.045. And when you multiply it times the 2.58, we're going to get 0.118. So you can put it in decimal, or you can put it in percentage if you want. This is the same as 30% plus minus 11.82%. So the lower bound, when you subtract, we get 18.18%. When you add, you get 41.82%. So this is what we call estimation. It is a range within which two values must lie. So this is a very critical topic which needs you to critically consider. All right. School modify, but this is where school begins. All right.
Wow.
Yeah. So now let's try together. Suppose you're given N, you have to find the sample size when our alpha is 0.10, our N, what we are looking for, our variance is 25, and our error is 4. That's 2. Find our N. If our level of significance is 1%, and our P is 15%, and our error is within plus minus 0.5%. And number 3, find the confidence interval. If our mean is 100 and our standard deviation, our N is 64, standard deviation is 24, our alpha is 0.02.
Yeah, so yeah.
Confidence interval is
talk face the issues that are on the table.
So please mute yourselves. So we have 10% here. And we have our N as 50. And our significance level as 5%. So another class, I'll group you into threes. Fred, Kai, Marcel, question one, into twos. Fred and Kai, question one. Marcel and Patricia, question two. Womba and Sylvester, question three. Tamara and Webby, question four. Please, let's move in that direction. I'll be writing, you'll be leading us through. Question one, what are we being asked for?
For question one, we're being asked for to find the sample.
The sample size, correct?
Is N. So N is calculated by Z squared multiplied by standard deviation.
Z squared,
standard deviation. No variance.
Okay. Yes, over.
Is squared.
Yeah. So the Z Z score is 1.645.
1.645.
Squared. Multiplied by 25.
Multiplied by what? 25?
Squared.
This squared?
It's already done.
So we don't.
Squared,
Then
divided by 16.
Divided by 4 squared. Correct.
Yeah.
Second team. N, which format do we use? Two.
The one with the probability. The one with PQ.
The squared PQ over what?
And
so what is our Z? What is our Z?
2.58.
2.58 squared times what? Zero 0.15 times 0.85 over what? 0.005 squared. Question 3. What formula are we using?
It's mean plus or minus Z. Then that says it's standard deviation in brackets over the square root of N.
What does that mean?
It's 100.
Plus minus?
Plus or minus should be, is it 2.33? And then we have open brackets 24 over the square root of 64.
Right, the answer you can find at your own time. Then number 4. Group 4. What formula do we use?
P plus or minus Z the root of PQ over N.
What is our P?
.1.
And our Z? $1.96. And what is our Q? $0.9 over 50. Okay, so capture this. This is your homework. I need the solutions for just these 4. We've started the groundwork for you. I'll just need the solutions for that.
Excellent.